All right, so for question 13, it is about congruent triangles and similar triangles. These types of proofs are always appear in section A2. All right, so let's see. Part A, proof triangle DEF is similar to triangle BAF. Okay, BDEF, ABF. Okay, so for doing this type of question, I suggest you to first point out the hint. You first show the hints. You first draw out all the hints first. All right. So actually, when you see two angles together, right, you can actually obtain that this one is equal to this one, right? Vertically opposite angles, right? Okay, and then let's look at other clues whether to see whether you can obtain some hints. All right. So EDF. So triangle ADE, this one, triangle ADE plus triangle CBE, this one is equal to 90 degrees. All right. So this one will be 90 degree minus triangle CBE, right? And for ADE is also equal to 90 degree minus triangle angle CBE, right? So you can find two angles together already. You can find all the two angles, right? So you can do the proof now. In triangle DEF and triangle BAF, right? Angle DFE equals to angle DFE equals to angle BFA. Vertically opposite angles. And secondly will be angle EDF equals to 90 degree minus angle CBE, whereas EDF and ABF is also equal to 90 degree minus angle CBE. Therefore, angle EDF equals to angle ABF. And eventually, we can prove that triangle DEF is similar to triangle BAF. The reason is AA, angle, okay? So these two triangles are similar. Perfect, right? All right, then let's look at the other hints. Let's see. Suppose ABCD is a rectangle, report of rectangular properties. AD is equals to BF equals to 25. So BF, this one is 25. The whole AD is 25. EF is 6. AF is larger than BDF. Okay, it's triangle BDE. BDE, a right angled triangle. All right. So now, how can we do this type of question? Okay. So, BDE, right? So let's consider this triangle. Okay, let me use another pen. BDE, BDE, this triangle, right? How can we prove? Wait, ABCD is a rectangle, right? So they must be 90 degree. And due to the similar triangles property, triangle DEF similar to triangle BAF as proved in part A. So angle DEF is equal to angle BAF, right? So you can automatically obtain the answer that because triangle DEF is similar to triangle BAF, proved, okay? Therefore, angle DEF is equal to angle BAF, all right? Equals to 90 degree. Corresponding angles, similar triangles. So as it is equal to 90 degree, you can automatically prove that triangle BDE is a right angled triangle. All right. Part B2. All right. So this will be a more complicated part. Okay. So find the perimeter of triangle BDE. Okay, triangle BDE. How much we know? We first know this is 31, right? And then how do we know DE? We can actually use the ratios. You know this is 25/6, right? Try to use the ratios here so that we can obtain some of the answers, okay? And assuming that we also know that AD is actually equal to 25 as well, all right? So if I let this DF as x, then actually AF will be equal to 25 minus x. And using the properties that of similar triangles, you can actually obtain the ratio and obtain x easily. All right, so we can write down now. Let DF equals to x, AF will be equal to 25 minus x, right? Because triangle DEF is similar to triangle BAF, we can use that DE over BA equals to DF over BF equals to EF over AF. Reason, corresponding sides, similar triangles, you're using the ratios, right? Okay, so DE, you don't know, okay, and never mind. DF is x, BF is 25, okay. EF is 6. AF is 25 minus x, all right? So you can actually form a quadratic equation that 150 minus x squared plus 25x equals to 150. X squared minus 25x plus 150 equals to 0. So you can use the quadratic equation that x minus 10 times x minus 15 equals to 0. Use formula 01 quadratic equation. X will be 10 or x will be 15. So actually, this clue is hinting you whether x should be 15 or 10. All right, because x now I let dx as x. Okay, so df is smaller, so df should be 10. All right, so x is 15 should be rejected. Therefore, dx equals 10 cm. All right, when df equals 10 cm. Okay, so when df is equal to 10 cm, then we can means x is equal to 10 cm. Then okay, it's already basically finalize all the things because you know this is a right angle triangle, right? So DE you can obtain is 8 because due to the Pythagoras theorem, right? And then the whole DBED is also a right angle triangle. So you can use that 8 square plus 31 square root is equal to BD, all right? So you can calculate that. Of course, you need to use proper steps. In triangle DEF, EF square plus DE square plus DF square equals to DF square. Pythagoras theorem, okay? So DE will be equal to root this one equals to 8 cm, all right? In triangle BDE, BD square equals to BE square plus DE square. Then DE BD will be Pythagoras theorem. BD will be equal to root 25 plus 6 square plus 8 square equals to root 1025 cm. All right. So we know that this is root 1025. DE is 8 and BE is 31. So we can calculate perimeter, the sum of the three sides of triangle BDE equals to BE plus DE plus BD equals to 25 plus 30 plus 8 plus 6, 25 plus 6, 25 plus 6 plus 8 plus root 1025, which is equal to 71.0 cm, correct to the nearest three significant figure. And this will be the solution for question 13.